Hello, welcome to my session of Live Coding 12-Factor App. I'm Emily Jiang from IBM. I'm Java Champion, Liberty Microservice Architect. In this session, I will briefly introduce the 12-Factor App, followed by live coding of coding two 12-Factor Apps. 12-Factor App is a methodology, best practices, and a manifesto published by Heroku. Let me first tell you about 12-Factor App in why, what, and how style. Why do we need 12 factors? 12-Factor define the contract between applications and infrastructure so that application and infrastructure can focus on their own domain so they don't step into each other's toes. What is a 12-Factor App? 12-Factor App defines clean contract between the application and the environment. 12-Factor apps are suitable for deployment on modern cloud platforms. It minimizes divergences between development and production, enabling CI/CD. 12-Factor app can easily scale up or down without significant changes. The reason it's called a 12-Factor app is because it has 12 factors, from code base to admin processes. I will briefly describe each of them later. How to build a 12-Factor app? MicroProfile and Kubernetes come to rescue. In my demo and also when I go through each individual factor, you will understand. Let's first tell you a little bit about MicroProfile. MicroProfile was established in 2016 by IBM, Red Hat, Payara, Tommy Troy, London Java community, and later on, Oracle, Microsoft all joined. It's lightweight iterative processes. It uses lightweight iterative processes. It's completely community-driven. Spec API TCKs are freely available in the public domain. MicroProfile community has over a dozen vendors and Java user groups, around 169 individual contributors, and also the community is still growing. About a dozen independent implementations. So here listed these implementations, like OpenLiberty, WebSphere Liberty from IBM. Red Hat has Quarkus, Wildfly, Soundtail, and together with some other companies, provide Payara, Apache Tommy, Halidon from Oracle, Patch Launcher from Fujitsu, and also it's other communities such as other companies, Cumulus EE, Hammer, Piranha. So MicroProfile adopts very iterative, rapid growing processes. So each year we have 3 releases. In February 2020, we released the MicroProfile 3.3. So in the next few slides, I go through each individual factors quickly and give you a few quick overview. Code base. One code base tracked in version control and many deploys. The best practice is to use GitHub. One 12-factor, one GitHub repo. The second one is dependencies. You should explicitly declare and isolate dependencies. You can use Maven or Gradle to specify your dependencies. The next one is config. You should store config in the environment. In this way, you can use MicroProfile config to inject a config property, and the property can be stored in the cloud infrastructure, such as Kubernetes config map or secrets, and etc. What is MicroProfile? MicroProfile provides a set of APIs for you to directly inject a set of properties. You can either use the programmatic lookup or via CDI injection. When using programmatic lookup, you can do config provider.get config and then config.get value and specify the config property name and the type. Or you can use the CDI, you can use @inject at config property and then property name, and then is the type. Backend services. You should always treat backend services as attached resources. In this way, you can easily swap the attaching resources. The way to resolve this is to use MicroProfile REST client. For example, the microservice A needs to use service B. So in service A, you can specify service B's interface, and then you can annotate it with register REST client. And then you can inject that REST client, and then you can freely call any method on that class. And then how can you bind the service B with the service A? Let's use MicroProfile config. That will be a fully qualified class name for that interface system client, and then the value will be service B's endpoint. I will demo later so you will understand it. So the next one is build, release, and run. Strictly separate build and release and run stage. You should consider adopting CI pipeline such as Tekton. The next one is the processes. Execute the app as one or more stateless processes. You should consider adopt a RESTful API. So in this way, all the processes are stateless, so you can easily scale up or down without losing any information. So the next one is port binding. You should export services via port binding. Don't hard-code your port. You use MicroProfile config to inject the port, and then you can use the cloud infrastructure to assign a particular port. The eighth one is concurrency. You can scale out via the process model. You can consider to use Knative auto-scaling to scale your processes depending on the load. The next one is the disposability. So your microservice should fast start up, gracefully shut down, and very resilient. So for fast startup, gracefully shut down, you should consider to use very lightweight runtime, such as OpenLiberty or Quarkus, where I will demonstrate later. And for building the resilient microservices, you can adopt a MicroProfile fault tolerance. MicroProfile fault tolerance offers these capabilities such as retry, circuit breaker, bulkhead, timeout, and fallback, and etc. to enable you to build a resilient microservice. So the next one is dev product parity. You should keep the development, staging, and production as similar as possible in terms of code, people, and environment. You should consider use operators to deploy in repeatable manner. The next one is treat log as event streams. The best practice is you should system out your logs, and then you can attach ELK can directly streaming out. The next one is admin processes. You should run admin and management task as one of processes, such as utilize the Kubernetes tooling, such as Kubernetes jobs, and etc. Don't hard code admin process in your microservices. So in summary, 12-factor can be achieved using GitHub, Maven, Gradle, and MicroProfile, and Kubernetes, and best practices. So how can I create a 12-factor app? You could either use is two available solutions plus others as well. But in this demo, I mentioned these two. In this session, I mentioned these two. You can either use start.microprofile.io or use upstate.dev. They are all open source. So in the next 20 minutes, I will create two microservices. One is service A on Liberty. The other one is microservice B on Quarkus. Let me share my screen. And then then they will talk to each other. So it's service A will directly call into service B. Okay, screen. In order to save time, I already created service B. So service B running. So I can, and then also I started the service B, and this is service B. So service B has an endpoint do something, take on pass param and parameter, and also is pass client service. It's JAX as resource. The service B is stateless process. So you can see here is application. So the endpoint will be a data and then client service, and then you can pass in the parameter, and also is started in the dev mode. You can see this started, and on the port is 8080. Okay, let me create my service A. So I go to start.microprofile.io. I want this to be on Liberty. I will choose microprofile version 3.2 on OpenLiberty. I want to choose the health and client server architecture. And then OK. So actually, this one. I can go to the service A, make it bigger. So I can show you the code. So service A is quite simple. For this, I particularly want to show you this endpoint. So it's this client directly call back to the server. So this is I mentioned earlier, service B's interface is do something, and the pass param is get operation. So I define this interface and annotate with register REST client, and then I can inject the REST client into my JAX as resource, and then I can call the operation do something. And how can I wire it up? How do I know where the service B lives? That's the service binding. So I use microprofile config. So that will be a fully qualified class name for this interface, and then /mprest/url. As earlier I said, that is service B lives on 8080 data client service. So I save that. So now I can start my service A on the dev mode, because it runs on Liberty, and Liberty offers the development mode. So basically, if you want to change anything without changing anything, you can see the changes straight away without doing anything. So it's automatically reflect the changes. So as you can see, it's like which feature has been added, and also it tell you it lives on localhost 9080. Now I go to localhost 9080. So this is directly the endpoint. So it's calling to service B. So this is that this is Quaker service B really. To demonstrate is really it is calling to service B. I can say on Thursday. Can see straight away on Thursday. So this is like wired them up is client service architecture. The other thing I want to show you is, as you can see here, I put some sleep and also the runtime exception to demonstrate this service is not stable. It's sometimes not working. Let's just try to demonstrate that. You can this time is really slow, and this is okay, and then it's not working. So this is the kind of I set up a scenario, real time scenario, and this is not reliable. Okay, next one I want improve service A. So for service A, so the first thing is in my response here. Actually, in order to return this one, I want to add something. I will say Emily is speaking at virtual conference. If I do something like this, if later I'll go to a IBM or IBM Think or some other conference, etc. I have to change this in this class and recompile this. So luckily, MicroProfile config can help you to externalize your configuration. So basically, I want to put this into a variable. So I can easily to say here is actually is define is conference equals virtual summit. So in here, instead of hard code this, I can use a variable. That variable I want inject a value. So I can use MicroProfile config directly inject the conference property. So which is a string conf. With a conf. Save this. So I save this. Let's go back here. See, Emily is speaking at Virtual Summit. So the other thing is, as you can see, sometimes not working. Sometimes it's you get exceptions, right? Sometimes it's slow. Let's use let's improve the resilience aspect of this service A. So what can I do then? So it's luckily MicroProfile fault tolerance can help you to improve the resilience. So in the service A, I can at least say retry. Once I have retry, and I will be able to get the good response all the time. See, good response, but occasionally it's still slow. So, but in some situation, mission critical situation, you want your service to be fast. So again, you use MicroProfile fault tolerance timeout. You say, okay, I want timeout. If you cannot come back within 100 millisecond. And together with timeout and best practice is to use asynchronous programming. So I can annotate with asynchronous So here I will return a completion stage. And here I will create a completion stage. Use the completable future dot completed future, and then I import the completion stage. Save it. Let's go back here. Let's say so the server is not up. So service A through a error is that unable to. So this is the beauty of the dev mode. So if something not working, and you will get an error. So here is it says I need to insert a bracket. Let's go to here. So it's a complaint. Need to insert this. Now is everything compiled. Now I can see my you can see it's all worked out well beautifully. So what happened underline? So basically is when I have a timeout, and you will get timeout if it doesn't return within 100 milliseconds. Will get a timeout exception, and then that will trigger retry, and then you get a good response back. The other best practices is to add fallback as provide some backup operation. So for example, here I say fallback, and then I define the fallback method. And I can say here this is my fallback. So this is very useful because in the cloud infrastructure, and sometimes things will go wrong and you don't know. So it's always good to provide some contingency plan. So this is briefly talk about wire the service together and increase resilience and configure it. So next thing is I want to Dockerize it and push it to the Kubernetes. So in order to do that, I just build it. Even verify, and similarly for the microservice, this is service A. For microservice B, so I can do a build as well. And then after the build, I can build the Docker image. I say Docker build the Docker image. So similarly for service A, I can also do a Docker image. I can copy a Docker file. So, and then I can build a Docker image. So it's the next thing is well, it's building, and then should look at the deployment. So I created the deployment in advance. So I briefly discuss with you about this deployment. So for two services, you have one deployment each. So for service A, you have image Liberty service A, and with this is the image and port 9080, and similarly for service B is 8080, and service A is exposed like HTTP on the by a node port 380. Service B is used cluster IP, so it's the service name factor up B service, and it's on port 8080. So the beauty is I didn't hard code the port and the host, and then in my Kubernetes deployment YAML file, I can see the backend, the service B, actually now lives in the factor app B service 8080. So in this case, my service is directly call this backend. And the other things, as you can see previously in my app, I have hard code the virtual conference, and now I can change it. In that case, in the future, if I go to different conference, I can just change this value without redeploying my application. And this is the macro profile health. Expose this endpoint can be plugged in to serve as liveness prop. Similarly, for this ready/health/ready endpoint as well. So now they all build okay. So service A finish building, and as well as service B. So I can actually, in order save time, I already started them, already deployed them. So they are running, and you can see is get services. Can see it's live on 380, right? 380. So if you go in here, 380. Localhost 380. So it's up. Value specified in the YAML file is used. Now it's working. Service B. So this is briefly did a demo to demonstrate how to build the 12-factor. Let's go back to the slides. Let me stop screen share. Okay, so I demonstrate how to use MicroProfile on Kubernetes to build a 12-factor app, and very flexible. So as you can see, the first one is the code base. So service A will be one, and service B will be another GitHub repo, and deployment will be checked in under its own separate GitHub repo. They are all under version control. Dependencies and all the dependencies for service A and B is all specified in Maven file. And config a backing service and port binding processes and disposability I demonstrate using MicroProfile. Build, release, run, and dev prod parity. I did all the development and push to the cloud myself. And logs I didn't demonstrate, but if you have log, use the system out. And concurrency, as you can see, I use the Kubernetes deployment YAML. You see the 2 ports signed up per service because replica is 2. So you can use the Kubernetes auto-scaling to auto-scale it. So admin process, if you have admin process, remember to use Kubernetes jobs. So this is the references. The things that I have demoed is in my personal GitHub, vSummit, 12-factor app A and B, and then deployment. And then some useful, OpenLiberty.io has a lot of MicroProfile guides if you want to know more about MicroProfile. And Quarkus.io similarly has a lot of information as well. So that is if you have any questions and etc. Feel free to get in touch to get connected with me via my Twitter handle is Emily FH Jiang. This is conclude my presentation. Hope you enjoy it. Thank you for listening. Bye.